So for the second part of 9.2, we are going to start scalar multiplication, okay? So we've done adding and subtracting. So now we're going to multiply by a constant. That's what a scalar is. It's just a constant that multiplies a matrix. Scalar multiplication is when you take that matrix and you multiply it by a constant. So back and forth. So if you look down here at this core concept, if K was my constant, you take it and you multiply every single term inside the matrix by that constant, and you get a new matrix. Okay? That's all that changes. So let's go over to where those problems start on the next page, number 5 and 6. Number 5, it wants 3 times matrix A. So I'm going to write out what that's saying here. So I have 3 times matrix A, and I'm just copying it from up above. Now, you could totally rewrite this like that key concept does, where it has 3 times 2, 3 times 8, 3 times... Or you could look at it like this. I'm just going to distribute here without having to totally rewrite it, because that just takes a lot of space. All right? So when I get my new matrix, it should still be the same size as matrix A. So it should have the same dimensions. I'll end up with a 2 by 3 matrix. So I'm going to take 3 times 2, I get 6. 3 times 8 is 24. 3 times negative 3 is negative 9. So that's the first row. Second row, 3 times 5 is 15. 3 times negative 9 is negative 27. And 3 times 2 is 6. So here is the scalar multiplication of 3 times matrix A. Number 6 wants negative 4 times matrix B. So I'm going to rewrite this out, showing my matrix B, which is a 2 by 2 matrix. So I know my answer will be a 2 by 2 matrix. So I'm going to take all of this negative 4 and I'm going to multiply it by every single term inside the matrix. So I get my new matrix. Negative 4 times 4 is negative 16. Negative 4 times 0 is 0. Negative 4 times 2 is negative 8. And negative 4 times negative 5 is positive 20. So there is negative 4 times matrix B. So on 7 and 8 here, it's taking scalar multiplication and using addition or subtraction. In this case, we're using subtraction on both of these. But I'm going to show you 2 different ways to do the subtraction. And you can pick which way is better. That's why I did 2 of those. Because addition, just add those corresponding parts, elements. All right, so it wants 5 times matrix A. So I'm just rewriting this out. Minus 2 times matrix B. Okay. Now, because this is actually a subtraction problem, when I distribute, I will distribute this 5 to everything inside matrix A. And then I'm going to just distribute the 2 inside matrix B. So 5 times 4 is 20. 5 times negative 6 is negative 30. 5 times 2 is 10. 5 times 3 is 15. So there's... So then, yes, that negative stays there as a minus. And I'm just distributing the 2. Whoops. Whoa, I don't know where that came from. So 2 times negative 3 is negative 6. 2 times 7 is 14. 2 times 5 is 10, and 2 times negative 9 is negative 18. Okay, so this is one of the methods. So you may like the other one that I'm going to show you next better, but I'm starting with kind of how we did subtraction already. So I'm not going to rewrite showing 20 minus negative 6. We're just going to say it and do it. So I'm going to take negative 20 minus negative 6. So minus a negative makes plus a positive. So it's 20 plus 6 is 26. And then I have negative 30 minus 14, so they're both really negative. Negative 30 minus 14 would be a negative 44. Then I have a 10 minus 10 is 0. And I have a 15 minus negative 18. So that really makes 15 plus 18, and that's 33. Write it out if you need to, showing the minus, negatives, and all that, because that, if you need to, that is where I see the most mistakes is in subtraction problems. All right, so let's try number 8. I'll just show you kind of a different method so we don't have to worry about subtraction. That's always nice. Okay, so it wants 6 times matrix A, so I'm just rewriting it. And if you want to just take these and multiply them by 6 and just write the matrix once, whoops, you can do that. I like writing it out because that's just me. All right. And then negative 3 times matrix B, or minus 3 times matrix B. Okay, so this time, yes, this 6 multiplies everything in this matrix. This time I'm going to use the negative as well and distribute it inside. This is the other method. But when you do that, in between changes to a plus because you moved the negative inside. Okay? So when I rewrite these, okay, I'm going to multiply 6 times matrix A, so I get 24, negative 36, 12, and 18. Now I have a plus because I'm multiplying negative 3 times everything inside. So negative 3 times negative 3 is positive 9. Negative 3 times 7 is negative 21. Negative 3 times 5 is negative 15. And negative 3 times negative 9 is a positive 27. And now it's an addition problem, so you don't have to worry about that minus and negative and all of that. Okay? So, take corresponding parts, 24 plus 9. We get 33. Negative 36 plus negative 21 is negative 57. 12 plus negative 15 is negative 3. 18 plus 27 is 45. All right, so that ends 9.2, and you can do the 11 problems from the practice.